move on. All right, so Fab Templates. So all the stuff that we've done so far is mostly to get the metal takeoff. And at least here in Fremont, usually our metal takeoffs happen a number of weeks before we even start doing fabs. So we can order the metal because the lead time on metal is pretty long. So what we're going to be doing now we're trying to get the fab tickets, which are the drawings that tell the shop exactly what to make and how to make it. So we're going to start with Fab Templates. So Fab Templates are sort of the base drawing for a fabrication ticket, and it contains all the graphics that you would see on a fab ticket, or most of the graphics, I should say. They're named by the fab number column in the UD window. So if you look over here, let me hit refresh real quick. This column right here, fab, is the fab number, and whatever it says here is determines which template it's going to use when it draws the ticket for these parts. It ignores everything that's in parentheses like this. So the fab number of this one here is just fab 1. The fab template contains all the graphics, like I said earlier. It's got all the notches with their notes, Feats, which are short for features, like gaskets and other miscellaneous notes. And they can have attached parts on them, which we'll go over tomorrow, or depending on how this lesson goes, it might be 2 days from now. So to open up a fab template, when you're in the BIM model, it's pretty easy. You can right-click on any of these parts in the list. So let's just pick a horizontal. I right-click on it, and I can say Open Fab Template. And that opens up the fab template for that part. The fab template has, like I said, it just has the graphics. It doesn't have any of the information in it. So it doesn't have the mark number, doesn't have the part number written here. All this stuff in the chart here gets filled out when you make the fab ticket. And you can also preview fab tickets as well, similar to how you right-click open the fab template. You can preview the fab ticket, so you can see what the fab ticket for this part is going to look like. So you can see it has the part number, the cut size, and its quantity. Though when you do a preview fab ticket, the quantity is always 1 because you're just previewing the one part. Many times, especially for horizontals, there might be multiple mark numbers with multiple different lengths, but they all have kind of the same picture using this sort of cut size as a variable. All right, so some of the fab templates, they're generated automatically by the Takeoff program. Actually, all of them are. It will look on the server for existing fab templates. So let me show you what that looks like. So if you go to your S drive and you go to Fabs, that Fabs folder has a list of parts and folders. So when it's looking for a fab template, or you're looking for a fab template manually, you can scroll down to whatever part number you're looking for, say the 2100, like I was looking at. And then these are the built-in fab templates for that part. Your server should have the same fab templates that my server does, so you should have gotten all these fab templates too. So the process that the Takeoff program goes through when it's making the BIM model is it will look in your jobs. Let me go to my jobs. So my job right now is in this training folder. This is my backend database. It'll look in Fabs dies for a fab template. If that fab template doesn't exist for that specific fab number that you've indicated, it will go on the server and look there. If it can't find that, then it will look back over here and look at the dot, or look for fab number 1. Fab number 1 is special. It's sort of the basis for all fabs. It'll look for fab number 1 here. If it can't find that, then it will go to the server and look for fab number 1. Anything that it finds off the server, it will copy in here, and that's why I have everything, all these other Fab templates in here. But all of them are made when you run the BIM model. So, any questions about Fab templates before I get too far?
I just wanted to point out that when you're looking at the part number there, right after the part number, the next number, that's your fab. So if that were fab
Yes.
1A, where it shows up in that window, it's 1A. So you can actually see which fab you're pulling from directly there.
Yes, exactly. So yeah, it has the part number, and then this number here is the fab number. Right now, everything I have is fab 1, but we'll be changing that today. Then this is the mark number, and then that's the final length. But when you're looking at file names, it's always the part number, dash, and then the fab number. So this one's a fab 1 as well. This is also a fab 1. And if we look at the server, this is a fab 1, fab 1B, 1L, and 1R. And of course, these are just drawing files, so you can open them to see what they have. And if it's something that you want, you can put this fab number into your UD data, and then the next time it makes Fab templates, when you run QBIM, it's going to copy this fab number over into your folder. All right. So, like I mentioned before, the fab numbers indicate which fab template to use. So anything that has any parts that have the same sort of notching, same gaskets, all that stuff, same graphics, more or less, will get the same fab number. So if I had, like here, I have a horizontal, and then I also have a horizontal with an SRT adapter here. If these two get the same, if these two parts, 2100, get the same sort of picture, same template, then you want to give them the same fab number. If you need to do something special on one of these, like in this case, I do want to pre-assemble this in some future, in a future lesson, then I will need to change this to a different fab number so this part could have a different picture in this situation. If you change the fab number of something, the mark number also changes in response. So two things that are exactly the same length and the same finish, and the only difference is the fab number, they will get two different mark numbers because the fab number is significant. It counts for the mark number. Everything with it, if you don't know, mark numbers they're interchangeable. So if you have a mark number like this one here is HZ1-3, because it has the same fab number, same length as every other HZ1-3, it should be interchangeable with all of them. They should all, if you're in the field and you're trying to find an HZ1-3, they should all be identical and they could all be used anywhere. So mark numbers kind of identify a unique part on the building. So all of these here that I'm highlighting, they're all HZ1-3, they're all the same length, at least right now they are. They all have the same fab number, so they have the same notches, the same holes, same everything else. All right, so let's play around with some of these Fab templates. You should have gotten a bunch of Fab templates from the server, like this one here. And what this thing has is what we call notches. This one already has a few in there. When you click on a notch, they're all listed here. It will show you what made up that notch, and we're going to make some notches today of things that need them. We'll probably start with the extended cover because I know that one's not on the server, so we'll need to add stuff to that. So there's one notch, and on the other side, is another notch. And these are number 7 holes, according to here, and to this description. And they're 5/8 of an inch from the left or the right end, and it's for the shear block clip. And we should be able to see that over here on any of these. The hole, it's a pilot hole or not a pilot hole, a clearance hole for this screw to go in, and then drill into the shear block clip to attach it. And if we look through here, if we look through the BIM model, there's a bunch of notches already in here. All these horizontals are all Fab 1, so they're all going to have the same notches. But let's look at the sill. Looks like it has the same 2 notches. You can see the notches in this model is in the BIM model as well. It's not just in the Fab template. So if let's find this particular head or horizontal. So this sill here has 2 notches, and when I click on it, it shows me what was used to make that notch, what subtraction was used. If I click on this notch here, same thing. And you can also see them if I swing my view around. Of course, it wanted to twist sideways. You can see there's the hole created by that notch, runs right into the shear block clip, just like we like. And they're everywhere. If we look through some of these other ones, even our F clips and T clips, they have some fabs on the server as well to put in the holes, for the slotted holes for attaching to the anchor or to the surrounding condition. So notches don't have to literally be a notch with saw cuts. They can be holes as well, like these here and the other ones that we saw. But they could also be notches. Anything that you would subtract from this solid to make it look right could be a notch. So let's make a few. I'm going to start at the top of the list. I like to work from the top down, even though this one's, maybe I should skip this one. Let's do it. So this is a tube. This is the door header tube. Or should I start with something that you guys probably have? Let's start with these. We'll start with an extended cover, because I'm pretty sure you guys have those in your own database. So this extended cover, it has a few notches that we need to add to it. If we look at the detail, which is on 554, if I remember right, it's got a few things going on. It's got, looks like countersink holes, 6 inches from each end, right? This one says at horizontal. Does that mean they're staggered? Maybe. That one's kind of tough to do at horizontal. Not sure why that is. And that looks like the only sort of notching that we may have to do. I mean, there may be something that I'm not seeing where this has to notch around something else, but it looks like to me that the only things we have to add to this are the countersinks. I'm not sure about this note. Maybe you guys know more about that one, but I'm just going to do countersinks both sides, 6 inches from each end. So I'll go to my BIM model, and you have a choice when you're adding notches. You can put them either in the BIM model, or you can put them in the Fab template. This one seems easy enough to do in the Fab template because I don't need to see all these other parts to place this thing. I know it's 6 inches from the end. So I'm just gonna open the Fab template and do it there. Now Fab templates always, they're always drawn in model space at about 30 inches, depending on the scale. It could be, you can see the scale in the upper right corner here. This is 1/3 scale. So in model space, this thing is 30 inches long. If it was 1/4 scale, it'd be 40 inches. And if it was 60 inches, et cetera, et cetera. That's because we don't want to have to do break lines or other weird things to be able to see what's going on this part. So this thing is 30 inches long, and I'm going to drop in a countersink here. There's the countersinks are actually in the library. You may not know this, but I believe it's under extrusions. And if you change this to take off holes and fasteners. There's a bunch of, someone went in and revolved all the countersinks. So what was this one? An 06 AS, which I don't know off the top of my head how big that is, but hopefully you guys know about WW tooltips. That's a command. Once you activate it, it says it's on, and now I can mouse over this thing and it will tell me in the little pop-up, hopefully you can see it in the video, that it's a number 8 by 1/2 inch flathead sheet metal screw. So going back over here,
And with WW tooltips, it's a toggle that when you open a new drawing, it's reset, so you have to toggle it on.
Well, it's actually it should be for the whole AutoCAD session. So I
For the
turned it
session?
on.
Okay.
Yeah, I turned it on this drawing. It should be on all these drawings until you close AutoCAD. And it's using, as long as your descriptions of the fastener or gasket are on the server. I don't know if it works on gaskets. Oh, it looks like it does. Then it will pull up the name that is on the server. So if there's something weird on your job where this isn't matching the server, heaven forbid, just be aware that it's only showing you the description from the server. All right, so it's a number 8, which these are number 7 countersink holes. That's not, oh, that's just a hole. Of course, the one that we need is not here. All we have are number 7s. This is 06 ES. Should be the same size. It's an 06, right? There's a chart. Let me pull up the chart. We live by this chart over here that I'm going to pull up. If I can find it. It's been a while. But it shows what sizes your holes should be. Probably need to add a link to this. That's not it at all. I don't think it's under Takeoff. It's standard. That don't look right. Fabrication standards. This sounds good. Yes, this chart. Most of our Takeoff people or Fab people have this chart printed out, and I'll put a link to it in the outline in the updated email. But basically, depending on what your fastener is, if it's a number 8 for a clearance hole, we would need to be drilling a number 17. If it was just a pilot hole, then number 30. We don't do pilot holes all that often. And that's for normal screws. This chart here is for screws. This chart down here is for bolts and punch sizes. So this would be like the anchors and the sill track or something like that. So this one, it said it was a number 8. I'm going to need a number 17 hole. And over here, when I'm inserting this extrusion, this one here is a number 17 countersunk hole. So this is the one I want. I think what the person did when they made this library is they just took the screw and they revolved it to have something to subtract. So it's not actually the right size, but as long as you call it out as a number 17 countersink for that screw, you should be okay. So you can drop that in. Also, the origins are messed up in that library. Someone very hastily made that. Still pretty handy though. So drop it in. They left this in, so I can erase that. And now I'm just going to use my UCS commands to rotate this thing. that. Oops. Not quite sure where this thing is going to be. Let's look at the detail. There's no like V groove or anything there. I'm going to just measure where it is. That's not a nice number, so I'm probably going to bump that to 1/2 inch. If we move this a 32nd upwards, then it would just be a 1/2 inch. So we'll do 1/2. So that way 1/2 inch, and then 6 inches this way. Now 6 inches on this 30-inch part is a good sizable distance across this thing. So I kind of want to make it look more to scale. So I'm not gonna, well, yeah, I'll put it right there. At least then in the BIM model, I'll see that it's 6 inches and I'll see where they are in the BIM model, which is also kind of nice. I'm gonna mirror this to the other side as well. So all parts in the fab are centered around the origin. So the origin is actually at the mid plane, at least up and down it is. So I can just mirror this around 0, 0, like that. Erase source, no. All right, so now I've got my subtraction solids in there. Let's make sure they're long enough. Looks long enough. Yeah. So I'm gonna run the notch extrusions command. So this is it over here, notch extrusion. So the first thing it asks you is to select the extrusion to notch, and you want to pick near the end where the notch is located. So I'm going to pick over on this end. Now, the reason why you're picking on one end versus the other is these holes are going to be 6 inches from whichever end, or they're going to be whatever distance they are from whichever end you pick. So if I pick this end, it'll be the nice 6 inches that I wanted. If I pick this end, then it's going to be, this is 30 minus 6, so it's going to be 24 inches from this end, which is not what I want. They'll be all weird on the BIM model. So make sure you pick the right side or right end of the part. And when you select the end, it always shows you half of it highlighted like that, just to remind you that you're working on this end of the part. The entities that make up the notch are these two little guys. And then enter. Are you sure you want to make it? Yes. And it erases and subtracts them for you and creates your notch over here. Cool. You can type in a description here. So some people are really good at typing descriptions. Some people aren't. A lot of the times it doesn't matter because anyone who sees this notch in AutoCAD can click on it and see what it is. I'm just going to put number 17, countersink. You could say more. That's up to you guys and your standards or your style. And I should be able to see it here. Looks good. Any questions about that so far before I continue? All right. I'm going to save this drawing. So once I've saved it, this notch is a part of this Fab 1 for this cover. If I go to my BIM model and I click, it says that there's that notch there, but it's not actually in here right now. If I right click and refresh what the BIM model is showing me, then it will pick up that thing, which I guess I put on the bottom. Oh, I put it over here. It's on that end. So you have to refresh to get notches that you've added to the Fab template to show up here. So that's what this refresh does. It makes sure that this part in the BIM model is synchronized with whatever is in their Fab templates. Conversely, there's this redraw Fab template option, which makes sure that whatever is in the Fab template is synced with the model, which can also happen where it gets out of sync. All right, let's continue with this thing. I probably should have put this on a vertical template. That's part of my problem here. So let's convert this to a vertical template. And to do that, I'm going to go over here to the layers. And this green border here is the border 1 layer. Let's turn that one off. What we want is border 4. Border 4 is a vertical template. And the vertical template only has one mark number here. But it also, you should also turn on the border for B. Yeah. This is what makes it a vertical template, this guy here. Where it says dimensions are from bottom of vertical, BOV, to top of horizontal or datum. It says BOV there. That's what makes it a vertical template. This chart is used by the Takeoff program to add the location information for different horizontals, which we'll get into later. But that's how you make something a vertical template. You also have to turn on your viewports layer for a minute and turn on these two viewports. So display viewport objects, yes. And then I usually turn off the viewports layer right after that. And then you want to right click on this thing and refresh it. It's going to flip it around. Now that it's on a vertical template, it knows to draw it in this different direction. Usually a vertical template, this view down here is plan view. So you want to make sure that that looks like plan view, and it does. Right, let's save that. That didn't change anything with my notch. My notch is still right where I put it. But I wanted to do that first before I started adding notes to the notch. All right, so next thing, let's add some notes. So I'm gonna there's a couple ways you can go about this. I'm just gonna start drawing stuff. So I'm gonna go linear, sure, quadrant, sounds good. 6 inches there. Could dimension that, but that seems silly. We also want the hatching, where we want to have a center line or something here. And you might not be able to see it on the video, but there's a gray line here for the countersink. Usually with countersinks though, I like to show them which direction the countersink is going. So there's a handy command for that called hatch faces. Right here, it's on the WW fabrication tab, hatch faces. And when you click on this, it takes you to model space and it just wants you to select the faces that you want to hatch. So I want to hatch that face, and this one's a little trickier to get. There we go. And hit enter, and it draws my hatches here for me in paper space, exactly where I want it, where I would want them. It sometimes draws them over here too if it can't quite figure out that side, but it didn't do that in this case. All right, then I'll draw some center lines, which I'll just use the line command. Put that on the center line layer. I found out that these need to be 0.7 long. That's about as little, as small as you can make it, and it's showing the dash. So if you care, like it's going to be that big if you wanted to show the dash. Honestly, it doesn't matter all that much. So I'm just going to leave them short like that. Kind of eyeball it there. Another trick is if you need to copy this from this view to this view. This one's pretty easy because you can just mirror, but yeah, let's just mirror it. I won't get into the crazy. So I'll use M2P. between this point and that point, like that. Don't erase. All right, and then I need a leader, right? So another trick with the leader, point to this thing here. And usually in Fremont, we say countersink for, and then whatever the heck this screw is supposed to be, which is 06AS. Because countersinks are interesting to cut. The shop likes to kind of do the depth and all that figuring out for themselves. At least here, that's what they do. So usually we just say countersink for whatever screw, and then the shop can figure out exactly how deep they want to make that. So I just put in brackets, square brackets, 06AS, and I'm going to run another command to convert this 06AS to its full description. And that is called insert descriptions. Where did I put it? I usually type it out. Insert descriptions. So when you run insert descriptions, you just select some objects. It could be notes, or usually it's just these kind of leader notes. And it will look for anything in square brackets, try and look that thing up on the server, and then replace it with the full description. Cool. Are these painted? These probably should be painted, huh? Anyway. Probably need a note on the other side. I probably could have arranged my leaders so that I would point to both of them, but I didn't. Oops. Yeah, I don't like this one. I usually like to make the arrow point towards in the same direction that you want the countersink to go. I might just make an exception for this one, because that's a really long note to be putting over here. So I'll just add another leader. And you could do that by mousing over this grip here, and you can say add leader. So anyone who sees this Fab template should know now where this hole is. Oh wait, they don't know where that hole is. I need the other dimension. And I pulled it from back here. So now they know where that hole is. You could put these up here as well, but I think it's pretty clear that they're in the same line. Let's make it super clear. Fix my other problem too, of that thing not being there. All right. So they should be able to see where this is, and they should know what size it is based on this note. So that's everything I need for this notch. Now, you want to attach this note to the notch. That way, if you, on say a future Fab template, you need to get rid of this thing, you can delete this notch and the note will go with it. Also, if you copy this notch from one template to another, which you can do by just hitting right click, there's copy and mirrored copy, which we'll do in a second. You want the notes to come with it as well. So to add all these things that I just drew as a note, you can right click here to the notch that you want to add it to and hit edit note. And this is similar to layout where you have this extra thing in the ribbon. So I want to add to the working set all the stuff that I added. So the dimensions, the note, center line, the hatching, all that stuff. There. Now that they're added, they're bright. And then I could save changes. So now when I select this notch, it should highlight not just the hole, but also all the notes that go with it. So I'm going to copy this really fast just so I can demonstrate. When you erase this notch, yes, I want to delete it. Notes go away. Looks like I didn't pick that hatch. That might be some kind of artifact. Yeah, that's not actually there. That was just regenning. So when you delete the notch, all the notes go, and when I paste the notch, all the notes come back. So that's kind of what you want. And you want to complete the notch with its notes before you start doing anything else. So, and also if the notch doesn't show up in this list, you can right-click refresh there, and it should pop up again. And I need this notch also on the other side. So I'm going to use mirror copy. So mirror that guy and paste it. And now I have it on the other side too. Now, so what it did here, it's because it's a vertical. Because it's a vertical template, it just kind of mirrored this stuff to the other side. So let me just fix that. Edit note. Usually with verticals, that is what you want it to do, because you're usually dealing with like left-handed jam, and you're mirror copying a notch that's also at the bottom of the vertical to the right-handed jam. But didn't quite work out on this particular instance. The notches still got mirrored over there. So actually, I'm just going to erase the notes from this guy. Everything else should be save changes. So I don't think I'm gonna run into a situation where I need the notes. Actually, I should have the dimension from the other side. Let me edit note. The other option to make notes is to right-click, edit note first. So right-click, edit note, and then anything you draw from this point will be inside the note automatically. So I actually do this probably more often than the other way. Get that lined up there. And then I guess I want my other dimension. Quadrant. Like that. Save changes. All right. So now I have this left notch here, has everything on it. And then I have this right notch, which only has the dimensions. I can't foresee the situation where I'll have one and not the other. Maybe I'll be wrong. So I'm just going to let the leader of this one also kind of serve as the leader for this one. All right, I'm going to save this thing. And close it up. Go back to my BIM model. I should be able to right click on this and hit refresh. And now I should have my holes on all of these. And because I made them 6 inches, I can actually see where these are. So I can see that they're like pretty much in the middle of nowhere on this BIM model. So that was a simple notch. Any questions about that? We'll do a few more.
Yeah, you did all the notching and everything on Fab 1. Wouldn't we necessarily only want to do that if we know that those notches are going to be consistent with that part all throughout? For instance, if there's some places where it won't have that notch, we'd want to do the notching on like 1A and leave 1 as just sort of the blank template.
Absolutely. So I mentioned before that Fab 1 is special, and Fab 1 serves as sort of the base Fab template for all future Fabs that you end up making. You usually don't want your Fab 1 to have any sort of notches that might be specific to like a particular area of the building or something that may change. I don't think this is going to change. I think these holes are always going to be there because this thing's always going to have to be attached to the vertical in some way, and 6 inches from each end seems like the typical way that it's probably going to be attached. So I don't have any problem with putting these notches in Fab 1 since they're always going to be there. But for other things like I can't even think of one in this tech wall. There might be other things that aren't that typical. They may be the first thing you encounter, but they won't be very typical. Those you may not want to put in a Fab 1. Usually Fab 1s, generally we want them pretty blank, pretty basic. We want it to be straight cut. We want it to be just to have the gaskets pretty much, and that's it. There's no gaskets on this part, but yeah, I don't really see a problem with putting it on this particular part. I think it's always going to have those 2 screws there. Might find out that that was a bad decision later, but right now it seems fine. So shall we try another one? Let's see here. It's another good part here that's missing something. We could do the caps. That seems bad. We can look at these. Let's just talk about fab numbers, because all of our verticals are gonna, all our pressure bars are gonna have some issues. I don't know if I want to get into that yet. Yeah, let's hold off on that. Let's look at, there's another good part. This guy probably has nothing on it. Yeah, let's just do this one, another practice one. So this is a T604-5332. It's the pressure bar. Trying to keep going over there. It's the pressure bar with the hooks. So it's the pressure bar that has the hooks for the extended cover here. And again, it drew it on a oop, that's my mouse wheel. It drew it on a horizontal template. So let's change this to a vertical template before we do anything. So going up to layers, turning off border 1, turning on border 4 and border 4B. Make sure it says BOV there. I'm going to turn on viewports. Turn on these 2 down here. Like that. Turn off my viewports layer. And then right click on this and refresh. And it flipped it around. And this looks like plan view. I'm putting this one on a vertical template because as far as what I've seen on this job, the only covers are the only place this is used is on a vertical. So vertical template seems okay for this. There is an argument to keep this on a horizontal template, but I think it's clear. I guess this thing won't have bottom vert stuff. I don't know if it. Yeah, we're gonna have a lot of fab tickets if we keep this on a vertical template because it can only put 1 mark number here instead of just putting a bunch and a bunch of different ones on the same sheet. Would you guys normally, I don't do tech wells very often. Would you guys normally do this on a horizontal template or a vertical template?
It depends. I mean, if there's any special holes that have to go in, yeah, for one or the other. Normally, I think you'd mostly see them on a horizontal template, but there's occasions.
I think on this one, actually, now that you mention it, let's look at the splice condition, because there's a splice over here, and I think you guys do something special over here. So this is 509. So this is a moving splice, and so your pressure bar goes down an extra 2 inches into the vertical below. It's like staggered. Your face cap is down here. So the pressure bar, depending on where the hole is, if there's a hole here, I don't know if there is, but if there is a hole here, it would probably have to be slotted so that this pressure bar can move independently of this vertical here because of that joint. I don't think there's a hole there. Where do we normally put the pressure bar holes? But that would be one situation where you kind of want it on a vertical template. If there is a hole here, you want it on a vertical template so that it's clear that this is the bottom of the pressure bar that you're putting a slot on. It would just make it look nicer. But let's see where the holes are for this thing. Let's go back to 554. Hopefully it tells us on the detail. Might not though, because kind of do standard stuff. It says 9 inches on center. So usually that means 3 inches from each end, right?
Typically.
Yeah. So 3 inches from each end would dodge that splice condition completely. So, and it'll be 1 inch into the other part. Is that true? Please be true. So this is the pressure bar splice. Looks like there's a gap. So this is where the pressure bar actually is, or the end of the pressure bar. I'll make that red. So the center of our hole will be 3 inches above that, which is into this vertical pretty decently. Yeah, that should be fine. So we'll just do 3. So we could, just looking at all that, we could use the same hole layout on this pressure bar as we could anywhere else. So that's what we're going to do. We're going to make these all Fab 1, and they'll all have the same hole layout. So let's build off of what we already have, because I believe the other pressure bar, this guy on the jam, already has stuff in it. So this is Fab 1. It's got L holes 3 inches from each end, 9 inches on center to attach to main body. That sounds pretty good. And here's our picture. Looks like it has some gaskets and our hole here. So you can copy this notch from this drawing. So I'll copy that into our other Fab template here. We'll see how well that works. Now, whenever you're copying notches from one part to a different part, it doesn't actually make the notch. It just pastes all the stuff that makes up that notch. So it pasted in my hatching, the leader, and the cylinder that I have to subtract here. From this, I can make my own, I can roll my own picture. So this thing looks like it's in the same place. Let's just see quickly how far away it is from the edge, 3 inches. So it's right where we want it. So I'm going to create a notch from this end using this cylinder. Yes, I want to make it. There we go. It's almost easier just to erase this thing and run notch extrude or hatch faces to get the solids. So do that because hatch faces is just too quick. This used to be a horizontal template, so I'm just going to move this up here because I expect the gasket to be there. I also, doesn't look like it's lined up when you zoom around a lot. I could draw a leader there. I don't think I need it. I do need the gaskets though. But as far as the notches go, that's it there. So right click on this thing, edit note, add to working set. I want this and that and that. That should be all. Save changes. And now I got my completed notch for this part. No, zoom extents. All right. Let's add some gaskets on this thing. Now, I don't need to mirror this or anything like that because it already says L hole 3 inches from each end and 9 inches on center. So I could have probably taken that same kind of tactic with the other one, with the countersinks, and not mirrored it and just gone with something like this where it says 6 inches from each end, both sides, something like that. Yeah, could have gone either way on that. Let's add the gaskets. So we got, go back to my 554 detail. And I don't know how you guys do gaskets, but I usually just copy them right off of this detail. Maybe it's not the best idea every time, but it's quick and dirty. Did I get the outline of that one? Okay. And these are 112s, and this guy here is a 113. So this is my same view here. Whoa, what's that? Did I not copy it right? I probably didn't copy it right. Specify point. Let's do that again. There we go. Now it's not the right scale, but it will be. Scale all these guys. Around that same point. And this is a 1/3 template, I believe. Should be. 1/3 is the minimum. So 1/3, you could just type 1/3. Works out great. And then I can do a mirror on this as well to get all these on the other side. All right. And now we can do some gasket callouts. $112. I'm gonna get all sneaky with this. Put the other one up here so I don't have to cross any leaders. And I got that right? 112's on the outside, yeah. All right, now similar to notches, we need to talk about features. Features work the same way, but they're for things that don't have something to subtract from the model. And it's good to make them into features because there are some things that we're going to learn much later that are kind of optional that use features. So, but they work exactly like a notch does. So if I click on this little down arrow, features are right here, create a fab feature. And it's going to ask me similar questions to the notch. Select the extrusion near the end where the feature is located, or none. So with notches, it has to be on one end or the other, but with features, it could be no end. It doesn't have to be either end. And most gaskets fall in that category. So I'm going to just say, I'm going to hit enter for none. So it just made a feature here. It didn't ask me to select anything because there's no model space objects for features at all. So I'm going to call this Gaskets 112, say. And then same way as a notch, you can right click on it and edit the note. And I want to add my 112 call out here and all the graphics. Like that. Now they're a part of that feature. Save changes. Do the same thing for the other one. Now, a lot of the stuff from the server doesn't have they're not, the gaskets aren't made as features. Probably should be, but I think they were all made before features even existed. But like I said, this is kind of optional, especially, I don't think you guys are using auto details yet, but I will teach you auto details later in these lessons. So this almost doesn't do anything until you start getting into auto details. But it's still a good practice. It does help you because it makes it really easy to copy this gasket from one template to another. But you should be making these gaskets in Fab 1, so they probably will be there already anyway. Just do it for now. There we go. And now we benefit from all the same stuff that we do for notches with notes. With these features, we can copy, we can mirror copy, we can delete, and everything goes away that we need to go away. All right, so we're coming up on 11. Are there any questions about notches and features? No. Okay, so some of the stuff that we have to look at here for your homework are the pressure bars. Let's just go over that real fast. Because the pressure bar at the sill and the pressure bar at the head and the pressure bar at the horizontal, they're all different. Lucky us. So this pressure bar here, this is the sill. It has a weep hole here, and it has one gasket 112 at the top, and then the normal 113 at the bottom. Right? At the head, now we have a weep hole still at the top, but the gasket's at the bottom, so it's kind of a different picture. And then at the horizontal, it has both 112 gaskets. I'm not going to open it up, but it has both 112 gaskets on both sides and that weep hole. So there's actually 3 different fabs for the horizontals, for the horizontal pressure bars. Luckily, you don't have to draw all those because they should already all exist. If we look at our S drive Fabs folder, and we look at that part number, which is 5319. I hope that's in here. Yeah, it is. Here's a bunch of different Fab templates that are already made for these. 1B, I believe, is for the sill. Let's take a look at that one. See, it has a single 112 next to the weep hole. 1M. What's 1M? Let's find out. This one's the one for the horizontal. It's got the weep hole and 2 gaskets. And then I believe it's 1H, 1T, I guess. Bottom, middle, top, B, M, T. This one's the one at the head, weep opposite the gasket. So you don't have to draw these templates. All you have to do is fix your data so that it uses those Fab numbers. So let's go back over here. Let's look at horizontal. This is my pressure bar here. Right now it's using Fab number 1. This is a horizontal, so I want it to be 1M, which is middle, right? For sill, same thing, pressure bar here, I want this to be a 1B. And for the head here, I want that to be a 1T. Save my changes. Ignore that message for now, we'll talk about that. And now I'll close this BIM model, close this Fab template too, after I save it. Then when I UPD this, I should get different pressure bar numbers. Remember, our pressure bars were all the same before. They were all Fab 1 at the sill, at the head, and at the horizontals. Now that they have different Fab numbers, I'll have I have a PB1-13C. It's hard to see. PB1-13C. Then up here I have PB1-13B. It's a different mark number. And then when I QBIM this, just do that little area. And now I have all these different fab numbers for all these pressure bars, 1Ms, 1Bs, whatever. And when I open the fab template, it's the one off the server. So there will be quite a few fabs on this elevation 2, that you can pull right from the server just by hunting a little bit. Save you a ton of time if you do it. Also, the benefits are you end up using the same exact notches on this job and the next job and the job after that, which if the notch is programmed for the quadra, will also get the same machining from the quadra. So then the machine programmer doesn't have to redo any of this stuff either. Because these notches, they are programmed against. They are, when Rick over there gets your fab release, he can open up the AutoCAD, he can see these notches, he can assign machinings to this specific notch so that whenever this notch appears, it does the same thing. So that's a huge benefit when you have those notches on the server. He doesn't have to reprogram them. So your homework is to add the notches and the features to all the vertical pieces. I'm not going to make you do all the horizontals. It's kind of a lot. If you want to, go ahead. But yeah, just focus on the verticals. Verticals are the same way. Like, I don't know if this one you'll have to make a notch for, but for the jams, you could probably get the fab number of the correct pressure bar off the server. I think it's just 1L and 1R. And then, get all the other parts. The doors might take a while. Don't worry about attach parts if you know what that means. Just get the notches and the fab features in there. Oh, actually, I did put on the homework. Sorry. I am mean. I did say find similar fab templates for the horizontal parts and use them by changing the fab numbers. So that's what I just did for the pressure bars. You should be able to do that for the rest of them. A lot of the fab templates that you will need, even on the verticals, are probably on the server. Like that guy is definitely on the server. So try and save yourself time, use the server. It's there for a reason. And that should be it. Any questions before we call it?
Nope.
All right. Help each other out. Make a bunch of notches and features. This is more of the fun part. All right. See you guys tomorrow.
Thanks.